Okay, so in this first question, we have this image of a line. We're also being told that the x and the y axes are defined based off of the tile pattern stuff that we've been doing. So x is our figure number and y is our number of tiles. We're trying to figure out how the line is growing. So what that means is we're trying to figure out the growth per figure number. So I think we might want to go back to the idea of using a table to kind of jump off from this question. So if I make a table for this, and this isn't the only way to do this, but I thought this might help. We know that the figure number has been defined as x for us, and we know that the number of tiles in that figure number has been defined as y. So if I take a look at the graph, I really don't know a huge amount of information other than I've got a line. But if you take a look at the y-axis, so the vertical axis, the one's number of tiles, there are no numbers there. So I have no idea what's over there. I do know the figure numbers though on the bottom. So I'm going to try to line up the numbers with that +3 and that +27. So if I look over at the graph, it looks like this point here is right at figure number 4. So I'm going to start at figure number 4, and then I'm going to go to the end of where that little triangle is drawn. And that looks like it's at figure number 7. Okay. So 4, 5, 6. All right, let's extend this a little bit. And 7. Okay, which makes sense because I've got that +3. So if we take a look back at the graph, I've got this +3 business, which if you take 4, you add 3 to it, you get 7. Okay, so that's good. At least I was able to see where the 4 and the 7 were. Now the next thing I'm trying to do is figure out that +27. Well, here's what I know. I know that from figure 4 to figure 7, my tiles increased by 27. That's about really all I know right now. So look back at my graph. I know that from the 4th figure all the way down to the 7th figure, this increased by 27 total tiles. Now, I also know that the graph is a line, so I've got this linear pattern to it. So that means that I know I'm adding the same amount every single time. So I think my job is to figure out, well, if over 3 tiles sets, I went 27, how far did I go from one to the next, to the next, to the next? So that's what I would like us to try to figure out. So I'm going to go from here to here, here to here, and here to here. I have to figure out what's being added every single time. So why don't you see if you can figure that out? So now there's a couple ways to do this. I think the most straightforward way to do it based off of the table is to see that I've got this 27 and I'm trying to split it evenly into 3 pieces. So I think what I'm going to do is I'm going to take the 27 and I'm going to divide it by, well, however many pieces I'm trying to cut it into, 3. So I want to be able to have the same distance or same amount of tiles that are being added every single time. If I divide that, I think I get 9. So if I go back to my table, I believe that 9 is being added every single time. So to answer the question, how many tiles are being added each figure? I would say 9 tiles are being added each figure. So this idea of growth from one figure to the next figure to the next figure to the next figure is one of the things we're really going to focus on today. It's actually the big thing we're going to focus on today. So make sure that you have everything written on this slide because we are going to be moving on. Now, one of the things I haven't talked about yet, but we're going to right now on the next slide, is the whole notation thing up at the very top. So what this section has been called, and it's got that little triangle with the y next to it and the triangle with the x. Let's talk about what that actually means. So what we've been doing with this whole idea of growth from one figure to the next is we've actually been talking about slope. So how much something is growing in comparison to a figure number. Now, we want to go by one figure number to the next figure number to the next figure number. But sometimes that's not the information that's given to us. We need to be able to figure out what it is per figure number though. So what we just did on the previous slide. So the idea of what we've been doing is finding slope. Now, when we talk about lines or linear equations or linear graphs like this, we do talk about one of the major components about it. Well, how's it growing or how's it shrinking? For lines, that's called slope. It also measures the steepness. So we can have a line that looks like it's almost flat, so just tilt it a tiny bit, or we can have a line that's pretty steep. That's the slope. That's what we're being told about this. Now, I wrote slope in a big, huge open area, and that's because we got a lot of stuff to put there. Slope can be identified many ways. So with that said, let's start adding stuff in for slope. Oh, and this image is also on that images sheet for you guys. So slope, I think the one that probably sticks with most people for the longest amount of time when they're thinking about slope is the idea of rise over run. So if we get rid of the idea of the tile patterns, because that was just a tool to help us get to these, we want to take a look at the graph itself. And if we look at the graph, we want to think about how much is the y value increasing or decreasing as the x value increases or decreases. Well, okay, y's and x's, we'll get to that in a second. Typically, we think about the up-down movement, so that's our rise, compared to the left-right movement, which would be our run. I think for slope, that's the one that most people remember for the longest. Now, rise represents your y's, because your y-axis goes up and down. So this can be identified as the change in y. The run is going to be your x's. So this could be your change in x. Okay, here's where that symbol now comes from. This whole idea of change in, well, change in, we have a symbol for in math. Actually, we have a lot of symbols in math. This is one of them. Change in can be represented by, and it looks like a triangle. So change in y over change in x. So the highlighting is really the translation of what that triangle is. This is also one of the letters from the Greek alphabet, so which you may experience in some of your future math classes or some of your science classes. It also shows up. Okay, so we've got this rise over run. We've got this change in y and this change in x. Then we've got this triangle y, triangle x. There's also a formula. So for people that are very formula driven, there's one of those as well. So this is, well, to find the change in things in math means to subtract them. So you're finding the difference between them. So we could do the difference in the y values. Now there's going to be two y values, that's why I use subscripts, over the difference in the x values. Two different x values, that's why I'm using subscripts. Now, there are many other ways to say this. And I'll get to, there's going to be one at the very end that we're going to use kind of our shorthand of, well, if somebody asks you about slope, what letter should you be looking for? It's kind of a dead giveaway when we're dealing with lines. So this could be the difference in y's over the difference in x. Ultimately, probably the one that we're going to see the most besides rise over run, besides the little triangle y over the triangle x, is the single letter that we use to identify slope. And that is m, lowercase m. So whenever you're asked to identify m in an equation, you're being asked to identify the slope. Now, previously, when we talked about the equation that we used, we identified m as the growth. That hasn't changed. It's still called the growth. So here we've got a whole bunch of different ways to identify what slope is. So now that we've got that, and we have our example here, let's see if we can find the slope of the line. So I'm going to take a look at the graph. The first thing that I want to do is figure out, so I'm going to use my notation. I have to figure out what the change in y is, and I'm going to put that on top, and then the change in x I'm going to put on the bottom. Now, there are many ways to do this. I'm going to stick with the subtraction idea. So what we could do for now, we'll even talk about just counting. If I take a look at the highest point, so I'm looking at that that change in y location, it goes up to 4 on top, subtract, and I want to see it goes to 2 on the bottom. So for the top, I'm going to put 4 minus 2. I'm going to do the same thing for the bottom, but just with the x's. So furthest to the right is 4. Furthest to the left is 0. So I'll do 4 minus 0. Now, I'm just going to clean it up. So that gives me 2 over 4, but that can be simplified. That's a half. Okay, so you may be asking yourself, well, if this is a tile pattern, what does that mean? That means that you would be adding a half of a tile every figure. That's what that means if we think about tile patterns. Okay, but that's our growth, which is our slope. All right, let's take a look at our starting value. All right, well, the starting value we can find from the graph. Remember that the starting value is just a single number. So I'm going to take a look at where my graph hits the y-axis. That's the one I care about. And if I look, it looks like that purple dot. So it looks like it's hitting at 2. So my starting value is 2. However, if I wanted to actually write out the y-intercept, remember that's written as a point. So it's going to be 0, whatever the starting value is, which in this case was 2. Okay, we have all the information. We should be able to write the equation. So let's plug in stuff where it goes. So y equals slope x plus starting value. And that's the equation for 4. All right, so here we've got another one. It's a tiny bit more complicated, especially question 6. So I think what I would recommend that we do is let's do question 5, then question 7, and then see if we can go back and solve 6. Okay, so question 5, we want to be able to find the slope of those two triangles. I want you to see my notation here, folks. I used M to represent slope, and I used a subscript with a capital A. What that's telling me is that I'm trying to find the slope of A. So that's the triangle I'm looking at specifically. Now, I don't have to do a whole bunch of work here. It's actually really nice because they already did it for me. See all the +4, +6, +2, +3? I already know what the signs are going to be. So I don't have to figure out the subtraction part. I can just use the signs that they gave me. So if I take a look at triangle A, specifically triangle A. Triangle A has a change in y for +6. Remember, it's the up-down part that gets done first. So +6 is going to go on top. Now we got to figure out the run part of it. Well, that looks like a +4. So we're going to put a +4 underneath. Now at this point, we know a positive divided by a positive is a positive. We can simplify 6 over 4 though. 2 goes into both of those. So I think the slope for triangle A is 3 over 2. Now, why don't you take a minute and see if you can do the slope for triangle B. And while you're working, I'm going to start working through it so you can check your work as you go. Looks like I got the same thing. So if we are on a single line, we should be able to answer question 7. So all of the slopes for this line should and will simplify to give us 3 over 2. So all slopes on this line will be 3 over 2, which we're going to need to be able to solve 6. Now, 6 is a little bit trickier. We know what the x portion is. We're told it's +3, but we don't know what the y portion is. So I think what we might want to do is dig back to our memory banks from stuff that we've done previously. And that was the idea of using ratios. I know that you guys did similarity back in Math 7 and Math 8. So that's what we're going to do here. We're going to try to set up 2 ratios. So I know the slope must be 3 over 2, period. I know that because it's on this line. I also know that the slope, by definition, is change in y over change in x, for sure. Okay, well, let's go up to triangle C. So if I go to triangle C, I know that the x is going to be +3. So I'm just going to go ahead and put, well, I know that that is supposed to be +3 from triangle C. I have no idea what the y is, but I don't want to have a whole bunch of notation, so I think I'm just going to turn it into y for now. We'll come back and put the little triangle in front of it. And I'm going to rewrite that equation. So I'll do 3 over 2 is equal to y over 3. We need to be able to solve that. This is that ratio comparison thing I was talking about from a couple of years ago. In order to do this, you may have been taught a couple of different ways to do this. I am a big fan of doing cross multiplication because then it eliminates fractions. You don't have to worry about it. So what we're going to do is we're going to multiply diagonally. So we're going to do 3 times 3. That gives me 9. Beautiful part, fraction disappears. We're going to multiply 2 times y, and that gives me 2y. I'm trying to solve for y though. Take a look at this. This is just a regular old equation we know how to handle. So I'm going to divide by 2. We know that 2 divided by 2 is 1. So this is going to be 1y. But 2 doesn't go into 9 evenly, so I'm just going to leave it as 9 over 2. You could turn it into 4.5 if you would like, or 4.5, or you can leave it as 9 over 2. It's fine with me. Then I'm going to go back up here, so I'm running out of space. I know that I don't need the 1 in front of the y. I just call it y. But then I'm trying to find out what the change in y is. Well, if you take a look back, I just dropped the triangle symbol so I didn't get confused by it. So I'm just going to put it back. I think that's my answer. Again, you could have said that triangle y is 4.5, or you could even say triangle y is 4.5. It's up to you. They all mean the exact same thing, and they are 100% equivalent to each other. So any of those answers would be correct.